Hi friends, today we are going to look at factoring by grouping. This is my third video in the series on factoring. If you have not yet watched the first two videos, which is factoring by greatest common factor and factoring by difference of squares, please go back and watch those first before proceeding. All right, factoring by grouping is what we use when we have four terms. This is an important way to factor. However, it's also a really important tool that we need for the next method that we're going to use. So, which is the AC method. So it is both useful on its own and as a tool. So factoring by grouping is when we have four terms. Now, not every polynomial that has four terms can be factored by grouping, but it's something to be looking for. So let me give you an example. So let's start with x cubed plus 4x squared minus 8x minus 32. And you notice that it has 1, 2, 3, 4 terms. And we want to think about, can I factor it by grouping? So when I say factor it by grouping, I literally mean group the first two, group the second two, and then we're going to find the greatest common factor of each group. Let me write that down. Now, personally, I like to underline the groups to mark them off as separate from one another. There's a lot of different ways you'll see teachers do this. Personally, I don't like to add anything in the polynomial because it could make me mistake a minus for a plus, or it could just interfere there. So I like to underline one once and then the other one twice. That's why I do that the way I do. All right, we're going to look at each group separately. We're not going to worry about them together. So we want to factor off the greatest common factor of this first group, x cubed plus 4x squared. So its greatest common factor would be x squared. I'm going to factor that to the outside, open parentheses, and write down what's left. So x cubed divided by x squared leaves me with x. 4x squared divided by x squared leaves me with positive 4. So in place of that first group, I would have x squared times x plus 4. Let's look at the second group. On the second group, I have a minus 8x minus 32. Now that minus is super important, and we don't want to forget it's there. So when we have minus 8x and minus 32, they do have a common factor. It's minus 8. So I'm going to write minus 8, factor to the outside, and I'll write down what's left. Minus 8x divided by minus 8 is just x. Minus 32 divided by minus 8 is positive 4. So I have x squared times x plus 4 minus 8 times x plus 4. Something amazing has happened. Each of these chunks that we have created has a common factor, and it is x plus 4. X plus 4 is now my new GCF to be factored out to the front. So I am going to factor x plus 4 out to the front. And then I'll write down what is left. X squared minus 8. So my factored form is x plus 4 in parentheses times x squared minus 8, also in parentheses. We want to check to see if it can be further factored. X squared minus 8. Well, it's two terms. x squared is a perfect square, but 8 isn't. So we cannot factor this as a difference of squares. So this is our final factored form for this problem. X plus 4 times x squared minus 8. This step right here is probably the trickiest one. When you match those common factors as the new GCF, write it one time on the outside, and then write down what's left. Let's look at a few more examples. All right, so in each of these cases, we have 4 terms, and we're going to factor them by grouping. So I will underline my groups in each case, find the GCF, and then factor it from there. So my first example, x squared plus 2x minus 5x minus 10. So my first group would be x squared plus 2x. My second group would be minus 5x minus 10. And I've underlined the x squared plus 2x one time and the minus 5x minus 10 2 times to separate them. All right, so first we'll consider this x squared plus 2x. Their greatest common factor is x. So I will factor that x to the outside and then write down parentheses x plus 2. And if you wanted to check, you could multiply that x back in to make sure that you got x squared plus 2x. All right, next, let's consider the second group, minus 5x minus 10. They have a common factor of minus 5. So I'm going to write this minus 5 to the outside and then write down what would be left, which is x plus 2. Minus 5 times x gives me minus 5x. Minus 5 times positive 2 gives me negative 10. Then we're going to notice, hey, this is cool, they both share an x plus 2. That greatest common factor gets factored to the outside, and then I'm going to write down what's left, the x minus 5. So my final answer would be parentheses x plus 2 times parentheses x minus 5. Okay. I'm going to make one change on this problem before I start. All right, here we go. So x cubed plus 2x squared plus x plus 2. All right, so we have 4 terms. We want to try factoring by grouping. I'm going to underline the first 2 terms, x cubed plus 2x squared, one time. And then the second 2 terms, plus x plus 2, I'll underline twice. So let's look at the first group. X cubed plus 2x squared has a common factor of x squared. And I'm going to factor that to the outside. And I'll write down x plus 2, which is what's left. Plus x plus 2, the second grouping, well, they don't have a greatest common factor, right? There's nothing that they share. So this is an important thing. We have to write down that they share 1. That's their greatest common factor. And it's a positive 1 in this situation. But we still have to write it down. And that's super important. It's a place where students tend to make mistakes. So the greatest common factor that comes out is positive 1. Positive 1 would be multiplied by x plus 2 to get x plus 2. All right. Again, let's notice that both of them have an x plus 2. So we'll write that down on the front, x plus 2. And then we will open parentheses and write down what's left, which is an x squared plus 1. So when we factor this, I'll have parentheses x plus 2 times parentheses x squared plus 1. All right, let's try another one. And practice on these is just how you get better and more comfortable at them over time. So my next example, I have 2x cubed minus 5x squared minus 4x plus 10. So the first group will be 2x cubed minus 5x squared, and the second group will be minus 4x plus 10. off of that 2x cubed minus 5x squared, I'm going to factor off the GCF, which is x squared. And then I'll write down what's left, which is 2x minus 5. All right, off of the second group, I have a minus 4x plus 10. The GCF would be 2, but I want you to notice something really important. When we have a negative sign in the middle, we keep it, but we're really careful when we do that factoring. So minus 4 divided by minus 4x divided by minus 2 would be positive 2x. 10 divided by negative 2 is minus 5. So I would have x squared times 2x minus 5 minus 2 times 2x minus 5. Now notice both of them have a 2x minus 5. If it didn't match, we did something wrong and we need to go back and check it. So I'm going to write down that 2x minus 5 in parentheses, and then I'll write down what's left, the x squared minus 2. Okay? As always, we want to check to see if anything can be factored further. X squared minus 2, well, it's 2 terms, and x squared is a perfect square, but 2 isn't. So there's nothing else we can do with that. My final answer would be 2x minus 5 times x squared minus 2. All right, next example. X cubed plus 3x squared minus 25x minus 75. Again, I will group them, first two and last two. And let's consider that first group. X cubed plus 3x squared, greatest common factor is x squared. And I could rewrite this as x squared times parentheses x plus 3. Well, let's look at the second group. I have a minus 25x minus 75. Remember, when we have a negative in the middle or minus in the middle, we keep that and write the greatest common factor. And then very carefully factor out that negative. So negative 25x divided by negative 25 gives me x. Negative 75 divided by negative 25 gives me positive 3. Hey, look, they match. So both of them share a common factor of x plus 3. I'll write that on the front. And then we'll write down what's left, x squared minus 25. And you notice I'm super methodical about how I mark these up as I go, and I'll encourage you to do that as well. When you can establish a routine for yourself for working through these problems, it makes it easier to know what to do next. All right, we've encountered something new, and that is we've factored it, but we can factor it further. Take a look at that x squared minus 25. That's a difference of squares. X squared is a perfect square, 25 is a perfect square. So we are going to keep factoring in order to have this in fully factored form. I will keep the x plus 3 in parentheses. And then in place of x squared minus 25, I'll write x plus 5 times x minus 5. Now we have it in a fully factored form where none of the pieces can be factored anymore. All right, last problem I have for you. I've introduced a second variable, and I want to tell you it's all going to be okay. We treat it exactly the same. Trust the process. So 4 terms, I'll again group the first 2 together and the last 2 together. We'll first look at the first 2 terms, x cubed plus x squared y. You know, let me pause. I'm not actually sure I read the problem. Let me go back. I got x cubed plus x squared y minus xy minus y squared. All right, now we're back on track. From that first group, the greatest common factor would be x squared. And then let's carefully factor out that x squared and write down what's left. So x cubed over x squared leaves me x. X squared y over x squared leaves me with positive y. So I have x squared times x plus y. All right, let's consider this second grouping. Minus xy minus y squared. Well, remember, if we have a minus in the middle, it stays. And the greatest common factor is a y. So I'm going to factor out a negative y. So minus xy divided by minus y is just positive x. Minus y squared over minus y is just plus y. Okay, so both of these share a common factor of x plus y. I'll factor that out to the front, and then I will write down what's left, which is x squared minus y. I would want to check that x squared minus y. X squared is a perfect square, but y is not. So this one is complete, like it's completely factored. We don't have to go any further. So my final answer would be parentheses x plus y times parentheses x squared minus y. All right, in our next video, we're going to use factoring by grouping as part of the AC method, which allows us to factor trinomials.